Now that we've reviewed exponent rules, let's look at an example problem. And this is Chapter 0, Problem 1 in your textbook. And this one here gives us the quantity -3 x to the 4th power y squared, the entire quantity, as denoted by the parentheses, squared. And we want to look at a couple of different ways for working this problem out and determine what our answer will be. So the first option that we have is we could expand this out based on our exponent rules, and we see that the entire quantity is squared, and so we would rewrite this as the base -3 x to the 4th power y squared, and we would put 2 copies of that multiplied together. That is simple expansion of our exponent. Furthermore, from that point, utilizing the commutative property of multiplication, we can rearrange sequential multiplicative factors together and get all of them grouped together to where all of the like bases appear sequentially. In this case, we see the -3 times the -3, x to the 4th times x to the 4th, y squared times y squared. And I hope at this point you're starting to think back to the exponent rules video and see where this is headed. When we have like bases multiplied together, what we find is that we can add the exponents. Now, the coefficients on the front, we go ahead and multiply together. -3 times -3, that gives us 9. Negative times negative gives you a positive. X to the 4th times x to the 4th gives you x to the 4 plus 4. And y squared times y squared gives you y to the 2 plus 2. And we end up with our answer, 9x to the 8th, y to the 4th power. So let's look and see how we could have ended up with this from a couple of slightly different ways here. When we look at this here, we can go back a single step and we can actually regroup and extract our exponent rule from this. When we go back to the step right here, which was the step that we saw at this point when we were doing our original run through, when we go back to that step, we actually see that we can apply our exponent rules and recombine. We have 2 copies of -3, so that would give us -3, the quantity squared, and then x to the 4th squared. We have 2 copies of x to the 4th multiplied together, and then y squared squared. And then we go apply a different exponent rule and realize that when we have powers raised to powers, they multiply together. -3 squared gives us our positive 9 again. X to the 4th squared, x to the 2 times 4. And y squared squared, y to the 2 times 2. And again, we come out with 9 x to the 8th, y to the 4th. So again, we have come out with the same thing. We could also have done this completely different from the beginning, utilizing our exponent rules and applied the global power here to every component of the base. Now, you do have to be careful here. As long as there's nothing but multiplication and division, you can do this. If there's an addition sign or a subtraction sign somewhere in here, then you cannot do it this way. The negative sign is a directional component attached to the coefficient in this particular case. You need to be able to convince yourself that this is indeed the case. But we could have written this as -3, the quantity to the 1st power, and this is just a bit of bookkeeping notation, x to the 4th, y squared, and then applied the sequential power rule to each individual base. So that would be -3, the quantity to the 1 times 2, x to the 4 times 2, y to the 2 times 2. And again, we come up with -3, the quantity squared, x to the 8th, y to the 4th. And then when we finalize this, -3 squared is 9x to the 8th, y to the 4th power. So we have 3 different ways that we have arrived at the same answer, and as a general rule, when you arrive at the same answer by multiple ways, you can have confidence that your answer is indeed correct.